Scenario. A meteoroid is in a circular orbit above the surface of Earth with a distant value r. Question. What is slash r the force or forces that are contributing to the centripetal acceleration of the meteoroid as it orbits Earth? Well, the answer. The summation of Fc, which is the centripetal force, is made up of different forces. The only force here that is keeping the meteoroid in its circular orbit would be the force of gravity. Force of gravity is what keeps it turning inwards, so it keeps going around in the circle. Sophia now says in the next question, I want you to correct the following statement. Because Sophia said the meteoroid here is actually exerting a torque on the Earth because there is a force of gravity that is applied to a distance r. Torque is equal to r times F, which is radius times the force. Well, if Sophia's right, I want you to think about it. Torque causes an object to rotate. If the meteoroid is causing a torque, that means you're suggesting that the Earth is rotating. Is the Earth rotating because the meteoroid is going around it? Think. That's not the case. The answer. The force that is actually exerting is actually parallel to the distance. Therefore, there is no torque. Torque is only possible when the force applied is perpendicular to the distance. So it should be looking like that. The equation Sophia had didn't say that the radius is perpendicular. That's why her assumption was wrong. Okay, so there you go. Torque does not cause the Earth to rotate in this case because the force is parallel, not perpendicular.